Hi everyone. I was sent a question about the last couple of problems that were on the algebra factoring packet. So I thought I would go ahead and talk to you about this one. This is the very last one, number 22. And if you remember when we talked about factoring completely, we wanted to look at the trinomial and determine if there was anything that any of the terms had in common first before we try and go to generic rectangle or anything. And so when I'm looking at this trinomial, I'm seeing right away that I've got an m to the fourth, an m to the third, and an m squared here, all three of those. So I definitely know that a common factor would be m squared, so I could pull that out. And it looks to me also like 8, 80, and 200 have a common factor as well. It's at least 4, but let's see if 8 goes into 200. I'm going to check really quick. I haven't checked that one yet. So I'm just going to do some real quick division. It does. It goes in 25 times. So I'm going to pull an 8 and an m squared. I'm going to divide that out of each term. And when I do that, I'm going to end up with 25 m squared here. And then I'm going to end up with 10 m, and then I'm going to end up with 1. See, when I multiply these back together, I need to end up with each of those terms separately. So, so now I look at this and I say, well, that's fine. This is all good, but I need to go through and see if I can factor that one as well. The question is, can this factor into two binomials? So at this point, I would go to my generic rectangle, and I would put my 25 m squared and my 1 in, and then my diamond problem where the product is 25 m squared and the sum has to be 10 m. So it looks to me like it's going to be 5 m and 5 m. This looks like it's a perfect square. I can go ahead and fill the different factors in. So it's going to be 5m plus 1, 5m plus 1. Sorry about that. Slip of the pen. In other words, it's going to be 8m squared times 5m plus 1, the quantity squared. So key to this is finding that common factor that's in each one of those terms and dividing it or undistributing it from the trinomial before you continue to factor. When you do that, then it should work out to give you your final form. And either one of those forms would be acceptable.